In this video, we'll look at solving triangles, particularly what to use. There are other videos on how to solve. I'm not actually going to solve, I'm just going to show you how to get started and how you know how to get started. There are 7 questions here for the 7 different types of questions that we'll see. Question 1 is a right angle triangle. We have 30 degrees and 42 centimeters, and we're trying to solve for this side. Since it's a right angle triangle, 2 choices, SOHCAHTOA or Pythagorean Theorem. But since we have an angle, automatically can't use Pythagorean Theorem, it's SOHCAHTOA. So let's label the sides. Compared to 30 degrees, this side's the opposite side. And compared to 30 degrees, this side's the adjacent side. So I knew to use SOHCAHTOA because it was a right angle triangle and because I was given an angle. And so what's my setup? My setup is which formula uses opposite and adjacent while thinking about SOHCAHTOA. Which one is O and A? It's tan. So I write tan theta equals opposite over adjacent. And now sub in tan of 30 degrees equals opposite, that's x, over adjacent, that's 42. It's easy to solve from there, but I'm going to keep going because I have lots of examples. Please watch a video if you're not sure how to solve that. The second question's also a right angle triangle. This time I'm given this side's 15 and this side is 11. Similar to the last one, I think, right angle triangle. So I can use Pythagorean Theorem or SOHCAHTOA, but since I want to solve an angle, Pythagorean Theorem won't work, therefore it's SOHCAHTOA. So let's label the sides again. This angle is x, so across from that is opposite. And I'm looking at this angle x, and this side here, 15, is the long side across from the 90. That's the hypotenuse. So which formula, think SOHCAHTOA, uses O and H? The answer, of course, is sine. So I write sine theta equals opposite over hypotenuse. So the sine of x equals opposite, 11, over hypotenuse, 15. Again, there are videos on how to do that. If you want to learn how to solve it, I'm just showing you what to use. The third question's also a right angle triangle, but this time we're given 2 sides and we're asked to solve for a side. This is the situation where you're using Pythagorean Theorem, not SOHCAHTOA. How come? No angles involved. You have 2 sides, 1/3 side. That's Pythagorean Theorem. So you start with c squared equals a squared plus b squared, and make sure to put the right thing in the c squared spot. What's c squared? The hypotenuse. What's the hypotenuse? 15. So you get 15 squared equals, and now your choice of where the other stuff goes. As long as the hypotenuse is in the c squared spot, I can make the a squared the x or the b squared. It doesn't matter. I'm going to make a the x, so this will be x squared. And then the b is 11, so this will be plus 11 squared. There's videos on this too if you need to know how to solve. I also recommend comparing these 3 questions, particularly 2 and 3, and look at the difference between what you had to do in 2, solve for an angle, versus what you had to do in 3, solve for a side, why one of them is SOHCAHTOA and one of them is Pythagorean Theorem. Well, after that, it's the end of the right angle triangles. So now we're done with Pythagorean Theorem and SOHCAHTOA. That means we have 2 choices, Sine Law or Cosine Law. Let's look at this situation. I have angle, angle, side given. So that's A, S. When you have angle, angle, side given, it's time for Sine Law. You could label the triangle. That helps usually identify what we're doing. So I'm going to label this, say, A. Let's call this B. And this is C, which means this is little side A. And this is little side B across from it. And this is angle C, so across from it is baby C. So we're going to use Sine Law. And since we're trying to solve for little a, I'm going to put that in the top left. That is, I'm trying to solve for little side a, so put that in the top left of my fraction. On the bottom, the sine of the angle across from it, that's the sine of a, equals, and now the other pair that I know b, and it's side b, so side goes on top, because I put side on top here, so this is b over sine b, and now I'll show you the sub in. The a is what we're looking for, x, over the sine of the angle across from it, sine of 61, equals b, that's this 22, over the sine of the angle across from it, sine 44. Please watch the video on sine law if you want to know how to solve that. Question 5 is also not a right angle triangle, so it's sine law or cosine law. In this case, I have side angle. I'm going to write that down, side angle. And notice the angle's not contained between the two sides. That is, the angle I know is not in between these two sides. It's side angle, angle not contained, which means sine law. But this one's a little bit tricky because I'm looking for pairs. You know, some students like when I draw these hot dog things. So I have this, I'm going to do sine law with, and this. Let's label this triangle to see further. Let's call this A, say, and this is B, and this is C. So the thing is, I can't solve x directly, but since I had side angle given, I have to use sine law. First I'm going to solve for angle C. You'll see what I mean. So let's set up, since I'm solving for angle C goes on top, which means it's the sine of C, sine of capital C, over lowercase c. And then I'm going to work with this pair, so that's the sine of capital A over lowercase a. Okay, so sine of C, which I don't know yet, over, that's why I put in the top left, over little c, that's 45, equals, and then I have sine of A, that's sine 101, over the side across from it, 53. And I would go on to solve that. There's a video on how to do that as well. But when I'm done, I'll have angle C, but not the answer I want, which is x. How do you calculate x? You would do x is in a triangle, therefore the angles add to 180. So you would take 180 degrees, and you would subtract 101, and you would subtract what you got for angle C. Let's call that angle C, a little angle symbol. And that would tell you what x is. So in this case, you can't solve for the angle directly. How did I know to use sine law? Because I had side angle, and the angle wasn't between them. So make sure to know the difference between these two, as well as the two coming up. And here I had to do 2 steps. Last two, well, you can probably guess what they are, since I've covered Pythagorean Theorem, SOHCAHTOA, and sine law already. My last 2 examples, let's look at this one. Side, and angle right between them, as opposed to here the angle wasn't between the two sides. That would have been this one. Here it's right between them. That's side, angle, side, where the angle's between. That's cosine law. So we're going to set up cosine law. Let's label this triangle A, B, and C. So that means this is little a, this is little b, and this is little c. Oh, and I haven't written where we're going to solve for. I meant to put on this diagram. Let's solve for this side, x. And since we're solving for little c here, I'm going to write the cosine law version with little c on the side. So c squared, here's cosine law, equals the other two sides squared, a squared plus b squared, minus 2 times the other two sides, a and b, times the cosine of capital C. And now we'd sub in, the c was what I'm looking for, the x squared, the a is 16 squared, the b is 12 squared, minus 2 times a times b times the cosine of the angle here, 71 degrees. And there's a video on how to do this too if you need to learn how to solve cosine law. Again, I would compare it to when you use cosine law, SAS, versus when you use sine law, SSA. Both have two sides and an angle, but cosine law, the angle's in between. The last situation you might get is side, where you're given 3 sides and trying to find an angle. That's a definite cosine law situation. Let's label the sides again. I'll choose different letters. That's A, B, C. I mean as in different letters that make me use a different formula. Since I'm looking for angle A here, I'm going to use the A version of cosine law. So A squared equals the other two sides squared minus 2 times the other sides, cosine of capital A, whatever was right here. So x squared equals b squared, so that's this one, 15 squared, plus c squared, that's this one. Oh, I know what A is. I shouldn't have written X there. It's a good thing I'm labeling my diagram here. I better finish. This was B, this was C, this is A. A is not X, X is the angle. Boy, oh boy. Let's start again. A squared. What's A? I know it. I'm looking for the angle capital A. But I know A squared. That's 19 squared equals B squared, 15 squared, plus C squared. That's 16 squared, minus 2 times 15 times 16, and then cosine of A. And then I would solve for A using this equation. All I'm left with is cosine A. There's a video on how to solve that too. There you have it. A situation where we're using SOHCAHTOA to find a side, SOHCAHTOA to find an angle, Pythagorean Theorem, as well as Sine Law to find a side, Sine Law to find an angle, Cosine Law to find a side, and Cosine Law to find an angle. Those are the 7 types of questions you're going to get.